everyone. My name is Maya Singh, and I am a product manager at Microsoft. Today I'm going to be giving an introduction to eBPF and the CNCF Sandbox project Inspektor Gadget. So what is eBPF? eBPF is in-kernel bytecode runtime used for tracing, security, networking, among other things on Linux. What's cool about eBPF is that it brings a lot of flexibility to the Linux kernel and that you can make changes to the kernel without having to wait for a new kernel release. Additionally, it has a very low strain from a performance perspective because it uses a just-in-time compiler approach, and it won't crash your kernel. eBPF programs run through a verifier to ensure they're safe. eBPF can be used in a variety of different ways. Tracing is a pretty common example because eBPF can be used to measure CPU usage, memory allocation, and similar metrics that you think of when you're thinking of the Linux kernel. And these metrics can be used for troubleshooting or observability. Additionally, there are many security applications of eBPF as well. It can be used to enforce access control policies. So you can whitelist or blacklist specific system calls. Those are the calls between the user space and the kernel space to ensure security of your applications. And finally, there are networking applications of eBPF as well. eBPF allows for packet filtering and modification within the Linux kernel. So eBPF is very powerful and has a wide variety of use cases, but it's not without its challenges. It has a pretty steep learning curve because it requires a deep level of low-level systems troubleshooting, and also eBPF has limited higher-level context. So with eBPF, you can gather a lot of very granular kernel-level data, but you're sort of missing the context of containers or Kubernetes. And that's where Inspektor Gadget comes into play. Inspektor Gadget is an open source tool and framework for data collection and systems inspection on Kubernetes clusters and Linux hosts using eBPF. I'll talk about the important components, first of which are gadgets. Gadgets are OCI images that include eBPF programs, metadata, and WASM. And these gadgets can be stored in a container registry, making it really easy to share and distribute them. Additionally, the real magic of Inspektor Gadget comes from its filtering and enrichment capabilities. So Inspektor Gadget is able to filter super granular kernel level data in a performant way and then enrich this data so that it has the context of containers in Kubernetes. Finally, Inspektor Gadget is a framework. It's built in a super modular way so that you can collect the data that you need from the kernel and then filter and enrich it and export it in a way that makes the most sense for your particular use case. I'm now going to give a demo of Inspektor Gadget on a Kubernetes cluster. We've done some pre-work already for the demo, so we'll be showing how we can use the kubectl Gadget plugin to deploy Inspektor Gadget and run the trace DNS gadget. What we're doing here is we're using kubectl Gadget deploy in order to actually deploy Inspektor Gadget to the cluster. And now what we're going to do is run the trace DNS gadget. We already have an application on the cluster that is going to simulate some traffic to sort of demonstrate the capabilities of the trace DNS gadget. What you'll see here is we're specifying the particular pod name, my app, where the application is, and we are going to be able to see the DNS queries that are trying to be resolved, and we've intentionally included some wrong URLs that are unable to be resolved so that you can very clearly see that with the trace DNS gadget, you can see the information of where in the Kubernetes environment this is happening and exactly the URLs that are having the response codes of errors or those that are successful. Alrighty, thank you so much for your time, and you can find us on Slack, GitHub, and our website. Thanks.